Alright, I thought I'd make a short video here doing another example of finding the inverse of a matrix and then using the inverse of a matrix to solve a system of equations. So let's speed this up a little bit. So we're going to find the inverse matrix, and so we're going to start with this matrix A, and we're just going to make it up. And so I'm just going to make it out 3, 1, 2, 1. And then what we're going to do is we're going to write that matrix, and then we're going to augment it with the identity matrix. So what the identity matrix looks like is 1, 0, 0, 1. And then we're going to perform Gauss-Jordan elimination on the matrix. So what I want to do is I want to this matrix here, I would like to change it into the identity matrix. So I want to get a leading 1, so I want row 1, column 1 to be a 1. After I get row 1, column 1 a 1, I want underneath it, I want to change that 2 into a 0. And then I want a 1 in row 2, column 2. And then I want a 0 in row 1, column 1. So that's what we're going for here. So we need to slow this down a little bit, and we'll go ahead and keep playing. Okay, so first thing is I want a leading 1 in row 1, so we're going to take a third of row 1, so everything gets multiplied by a third. So I went ahead and wrote that down. So in red's what's changing. So 3 times a third is 1, 1 times a third is a third, 1 times a third is a third, and 0 times a third is 0. So that's where that top row comes from. We didn't do anything to the bottom row, so that it is as is. Alright, now what we would like to do is, you see that 2 in row 2, column 1, we want to change that into a 0. So what I'm going to do is I'm going to multiply row 1 by negative 2, and then we're going to add that to row 2 to eliminate that 2 there. So you have row 2 is equal to negative 2 row 1 plus row 2. So I'm going to go ahead and write this out. So the top row is unchanged, and it's the bottom row that's going to be changed here. So I'm going to write it all out, then I'll mention what happened here, as I have a hard time writing negative 2/3. Okay, so we took the 1 in red so we're looking at this one right here. I took the 1 in red and I multiplied it by negative 2, and I added it to 2. So the negative 2 and 2 makes 0. Then I took the 1/3 and I multiplied it by negative 2 and added it to the existing 1. So if we got 1 whole and we're subtracting 2/3, we got a third left over, so that's where that 1/3 comes down to here in red. Let's see, right there. And then we're going to take 1/3 and we're going to multiply by a negative 2 and get negative 2/3. Multiply the 0 by negative 2, we get 0, and so the 1 just stays 1 right here. So now what we're going to do is, I want that 1/3 that I've already put a dot under. I'll put a little bit more of a dot. We'll try a little bit more of a dot. We want to change that into a 1. So we're going to multiply row 2 by 3 to a fraction buck. So row 2 is going to be equal to row 2 times 3. And let me fix something here, just proper notation. We should put lowercase here. It doesn't matter a whole lot, but I'll try to stay with what the textbook was doing and what I was doing in class. Okay. So doing this, top row's unchanged, so I'm just going to go ahead and write it. The bottom row, I'll go ahead and write it, and then we'll talk about it. So 0 times 3 is 0. The 1/3 times 3 is 1. Negative 2/3 times 3 is negative 2. And the 1 times 3 is 3. So I almost got the identity matrix. I got 1, 0, 1, and then I got a third. So we got to get rid of that 1/3. So what we're going to do is we're going to take the second row, and I'm going to multiply it by negative 1/3, and then when I add negative 1/3 to the existing 1/3, I'm going to cancel them out. So we're going to take row 1 is going to be equal negative 1/3 row 2 plus row 1. So I'm going to go ahead and write the bottom row because nothing has changed, and then uh, we'll write in that top row too, and then I'll explain what happened. Um, so when I multiply the 0 here, let me see if I can mark it. This 0 here, if I multiply by a negative 1/3 and add it to 1, it's still the same. 1 times negative 1/3 and then added to the 1/3, that's going to give us 0. So we got the identity matrix. And then what happened over here is we had negative 2, and then I'm going to multiply it by negative 1/3, which makes it positive 1/3, and then I'm going to add it to the 1/3. So I'll have 2/3 plus 1/3, which makes 1 whole. Then we're going to take the 3, and multiply it by negative 1/3, which makes it negative 1, add it to the 0, and we get negative 1. So what I've highlighted in this kind of purple or whatever, that's your inverse matrix, and I may have written it already, so I apologize if it overwrites here. Let's see. Yeah, I did write it already. So that's finding the inverse matrix using Gauss-Jordan inverse matrix of A. If we go on to the next screen, that didn't do what I wanted. Let's see, how do I do this? I'll probably hit the play again. Okay, there we go. So I'm going to go ahead and write that matrix A again. And A inverse is what we just found. So there's that matrix there. And what we're going to do here is we're going to verify that when I multiply A and A inverse, I get the identity matrix. So the identity matrix is going to be 1, 0, 0, 1, and so if we do the multiplication here, I'm going to do first row. So this is where we go make the sound effect. So the 3 here times the 1, and then the 1 times the negative 2. So we'll have 3 plus negative 2. And that's going to be 1. Let's get rid of that out of the way. And then, so that'll give me the 1 there. And then 2 times 1 and 1 times negative 2. It's going to give me 2 plus negative 2, which is 0. So that's good. Then we're going to do first row times second column. So 3 times negative 1 and 1 times 3. So you get a negative 3 and a 3, which makes 0. And then you have 2 times negative 1 and 1 times 3. You got negative 2 plus 3 will give you 1. And this is the identity 2 by 2 matrix. So that's kind of the fancy name for it. And then I'm going to go ahead and you can verify this on your own and just watch. But if I do the other multiplication on the other side, I'm going to get the identity. So I can multiply on either side with the identity, the inverse, and I'll get back to the identity. Okay, so again, we get identity 2 by 2. And so this is kind of like, the opposite of multiplication is division, the opposite of addition is subtraction. So we're doing this inverse operation to solve an equation. So let's do an example where we solve an equation here. So let's solve 3x plus y equals 2, and 2x plus y equals 8, using inverse matrix. Okay. So we're going to go ahead and write our matrix A. Matrix A is only going to be the coefficient. So, oh yeah, and I forgot. Just clarification here. This y here, I accidentally wrote it as 1 in the excitement of the problem. So we're going to go ahead and we'll write that just the coefficients of the variables. 3, 1, 2, 1, and that's going to be our matrix A. And then we're going to have a vector, which is just a 2 by 1 matrix. It's a fancy name of calling it as a vector. And we're going to put the variables x and y, just like that. And then matrix B will be another vector, and it's going to be the coefficients that it's equal to. So how we're going to write our matrix equation is A times x is equal to B. And I'll go ahead and we'll write in the matrix A, matrix x, and that's equal to matrix B. So I left myself a little bit of room. I know that what's going to happen in the procedure. So as clarification, if I did this multiplication on the left-hand side, we'd do 3 times x, which would be 3x, and then 1 times y, which would be 1y. And that would be the top entry after the multiplication. So you'd have 3x plus y, and then on the other side is equal to 2. So that represents the top equation. Then the bottom we would have 2 times x and 1 times y, so we'd have 2x plus y, and that would be the bottom entry, which would be equal to 8. So we have proper representation. So we did all this process of finding the inverse matrix so that I can take this matrix equation here, that one there, ax plus b, and we can use the inverse to solve for it. So we already did the multiplication to verify that we get the identity matrix, and when we multiply something by the identity matrix, it doesn't change it, it just keeps it the same. So kind of like dividing both sides by like 5 if we're solving an equation or something like that. Here we're going to multiply both sides by A inverse. I'm going to erase the B just so I have a little bit more room. So I'm going to multiply the left side and the right side by A inverse. And you got to be careful here. So we saw an example in class where we saw that matrix multiplication was not commutative. So we have to do it. Make sure we do it on the left-hand side. So we'll go ahead and we'll multiply both sides by the inverse matrix. And so let's see what happens. So we get the identity matrix. We already did that multiplication on the last screen. So I'll underline it blue, and then I'm going ahead and do the multiplication over here. So then we go for the first row times the only column. We have 1 times 2, and then negative 1 times 8. So you have 2 minus 8, which is negative 6. And then negative 2 times 2, which is negative 4. 3 times 8 is 24. And so you'd have negative 4 plus 24, which is 20. When I multiply that identity matrix 1, 0, 0, 1 times the xy, we'll be left with just the xy. And then that'll be equal to negative 6 and over 20. Okay, so two matrices are equal if they have the same dimensions which these have, and then the corresponding parts need to be the same. So the x is going to be negative 6, and the y is going to be 20. Okay, and we'll do one more example. So this was using inverse matrix, and before that we found the inverse of a matrix. So we'll do one more solving a